Hey, welcome everybody to CML Online, your CSEC mathematics expert. And also a big shout out and a big welcome to those of you who clicked on for your 100% free paper 3 solution. And today, we're going to look at the paper 32 from January 2020, question 1. So let's begin. So it reads as follows. A hardware store has a sale on hammers, drills, and spanners. A hammer is sold for $15, a drill for $75, and a spanner for $25. Customer A bought 9 hammers, 14 drills, and 2 spanners. And customer B bought 8 hammers, 6 drills, and 7 spanners. Question says, construct the following matrices. Matrix P of order 3 by 1 to show the prices of the items on sale. So right away, what do we notice about the information in the question? Just take a second and see if you can answer. Right? Anything comes to mind? Well, when I read through the question, I realized that there were hammers, drills, and spanners in a particular order. Hammer, a drill, and a spanner. And then again, hammers, drills, spanners. Again, hammers, drills, and spanners. That's interesting because just after they place these things in a particular order in the question, then the idea of matrices was introduced. The question is why? Why was the idea of matrices introduced right after the question? The answer is a matrix is an ordered arrangement. That's very important. So the matrix is an ordered arrangement, and the order of the tools in the question is indicative of how your matrix should look. So I'm seeing a 3 by 1 matrix, which means 3 rows and 1 column. So to get the prices, we will have to put the prices of each tool in that particular order. So the first will be a hammer, $15. The second will be a drill, $75. And the third will be a spanner, $25. So your matrix should look like this. Any questions there? Okay, awesome. So the matrix should be P is equal to $15, $75, and $25. Right, pretty much straightforward. The next part of the question reads, we need to construct the matrix N of order 2 by 3 to show the number of items bought by 2 customers. Now, if we read through the question again, we can see the customer A came first and customer B came second. And the numbers associated with customer B, is 9, 14, and 2. And customer B will be 8, 6, and 7. So we have the matrix of order 2 by 3. We have 2 customers, which implies that the 2 should relate to the 2 customers, A and B, in that order, and the 3 should relate to the items that they both bought. All right, so since we have 2 rows, 2 customers, then each row should be a customer. And 3 columns, each column should be a particular tool. So your matrix should look something like this. Actually, exactly like this. Any questions? Awesome. Let's go on to, that means customer A is the first row and customer B will be the second row. All right, pretty much straightforward. Next, it says calculate the matrix, calculate using the matrix method, the total amount spent by each of the customer. So using the matrix method, we need to calculate it. Now, simply with all the matrix method, we will need to multiply the price of each tool by the number of tools. So we know that definitely there's going to be multiplication involved. But the question is, how should we arrange the matrix to engage in the multiplication process? So either we can have this matrix P multiplied by matrix N, or should we have matrix N multiplied by matrix P? The answer lies in the order of each matrix. So let's check out the order of each matrix, and then we make a decision. So the order of this matrix here is going to be 3 by 1. The order of matrix N will be 2 by 3. The order of matrix N down here, again, the same thing as up here. And on this side, it will also be 3 by 1. A good indication of whether or not you can multiply two matrices is to check that this last number here matches. It does match with the two matrices arrangement on top here, but it matches down here. This 3 matches with this 3, right? We can clearly see that this will be the order in which to multiply the matrices. It will be matrix N multiplied by matrix P. Let's proceed to do that. You have NP, which means N multiplied by P. And then we arrange the matrices together. This is matrix N multiplied by matrix P in purple. And then it's going to be this row by this column, which is 9 by 15 plus 14 by 75 plus 2 by 75, which is this row by this column, 9 by 15, which is what we have here, 14 by 75, which is what we have here, 2 by 25, which is what we have here. And then for the second row, it's going to be 8 by 15, which is this, plus 6 by 75, which is this, plus 7 by 25, which is this. If you multiply and add it, the top and the bottom, you will get 1235 on top and 745 below. And we know that each row represents a customer. Hence, we can clearly see that customer A spent $1,235 in the hardware, and customer B spent 745 customers in the same hardware. All right, pretty much straightforward. Take a minute and see if it makes sense to you. Awesome, we're back. Let's continue. Let's continue to this question concerning, actually this is going to be linear algebra, right? So let's read the question. Teacher Mabel is providing a meal for all the junior students in her school. Each student will have either a hamburger or a pizza. The cost of a hamburger is $4, while the cost of a pizza is $5. Let X represent the number of hamburgers and Y the number of pizzas that she buys. All right, so the print is a bit faded, but I hope by reading it, you'll understand exactly what the words are. So part 1 says, fill in the missing equations / inequalities in the table below to represent the condition given in column 2. So this is column 2 here. This is the condition. Let's read the condition, choose out the important words, and then write the equation or the inequality. So each of the 220 students must get one meal. That can be interpreted as everybody gets exactly one, but to be on the safe side, we're going to look at must get one meal as greater than or equal to, right? So that inequality actually wouldn't be an equation, it's going to be an inequality. It will be of this construction. So the number of hamburgers plus the number of pizzas is greater than or equal to 220. So hence, if X represents the number of hamburgers and Y represents the number of pizzas, then X plus Y is greater than or equal to 220. Any questions there? Awesome. Let's read the second part, part B. Teacher Mabel has no more than $900 to cater for the meals for all the students. That's definitely a constraint. So just by the wording alone, we can recognize that she cannot spend more than $900. So immediately we see this part of the expression means she can only spend up to $900, which means $900 or less. So if one hamburger is $4 and one pizza is $5, then the total amount of money is going to be 4 plus X plus 5 plus X. It should be maximally $900, or we can represent it as 4X plus 5Y is less than or equal to $900. Take a second and see if it makes sense to you. You guys awesome. All right, let's continue for the second part of the question. So feel free at any time to stop the tape, to go back, or to write down stuff. All right. So this part of the question deals with the graphing of the linear of the inequalities. So let's read the question. It says the line corresponding to the inequality X greater than Y is shown on the graph below, which is this line here. On this graph, draw the lines corresponding to the other two equations, inequalities in the table on page 6. That's the table we had from before. Those are going to be the guiding expressions which will tell us how and where to draw a line on this graph. So we're going to open up our bag of tricks, as it will, for the linear programming. So the linear programming method via graph. So one of the first things you want to do is write down all expressions. Okay, as we have here, this expression was given to us, I believe, yes, already. And we formulated, we came up with these two. All right. So the second step is we're going to replace all inequality signs with equal signs. So looking at these inequalities here, we're going to put equal signs in place of all of them. So it will look exactly like this. All right. Next, for all equations in 2 above, except x equals y, we're going to set x to 0, find y, and plot it. So let us use equation 2a as our first example of this instruction. Awesome. So we say for equation 2a, let x equal 0. Hence what? 0, therefore 0 plus y equals 220. If x is 0, then 0 plus y equals 220, right? Pretty much straightforward, but 0 is really nothing. Hence, we can say y is equal to 220 and plot it on the y-axis at this point. Okay? Right, and there's a close-up, because we saw a close-up there. It's going to be 220. And we are now all set to execute the second instruction. The second instruction is set y to 0, find x, and plot it. So we're going to set y to 0 now. Let y equals 0. Then, therefore, x plus 0 is going to be 220. Hence, x will be 220, and we plot it. So we come down here and we see 220 on the X, that should be here. And we just plot it. All right, pretty much straightforward. Any questions, you can put it in the comments. What comes next? We're going to connect the points. Let's connect these 2 points here. And voila, that's basically for the first equation of what we have done. Okay, so we have that equation, the first equation there in check and on the graph. So now let's go on to the second equation. 4x plus 5y equals 900. We're going to execute the very same 3 instructions. So for equation 2b, let x equal 0. Hence, 0 plus 5y equals 900. Now if x is equal to 0, then 4 by 0 will give me 0. That's how I got the 0 here. Plus 5y equals 900. Then by some algebra, we solve for y. Y is equal to 900 over 5, which is 180. Hence, y is equal to 180. We're going to plot that point on the y-axis, should be here. And we continue to set y equals to 0. So first we set x equals to 0, then we set y equal to 0. Y equal to 0 makes this expression here become 0. So it's going to be 4x plus 0 equals 900. Let's see if we have that. Right? Exactly the same. 4x plus 0 equals 900. 0 is really nothing. Hence, by subject of the formula, make x the subject of this formula. So x will be equal to 900 over 4, which is 225. X is equal to 225. So we're going to come on this x-axis and plot it. And draw the connecting line as well. Okay, so that is equation, the second equation. We put a check mark by it. And also this equation was already done, right? So we have completed all 3 equations and drawn them on the graph. It's 2 marks, so it shouldn't be too difficult. Just follow these steps, and as long as these equations that you got at the beginning were correct, then this should be a simple process. Any questions there? Awesome, great. So let's continue. Don't forget that's line x plus y equals 220, and this is line 4x plus 5y equals 900. And now it says use your graph. Using your graph or otherwise determine the maximum number of hamburgers and pizzas that teacher Mabel can buy. So in order to do that, let's bring back up the guiding expressions. We're going to try to take these expressions and represent it on this graph. Now, we don't bring back the ones that where we converted these inequality signs to 0. These are going to be the original expressions that we have. So what we're going to do, we're going to shade in the spaces and show you exactly and demonstrate exactly the region that satisfies all 3. Now, in the exam situation, it may not be wise to exactly shade as I'm about to shade here. So just simply put some strokes or some dots, light dots, not many, just to have you clearly identify the shaded regions to yourself and the invigilator or the person who's correcting your script. All right. But for demonstration purposes, I will shade it a little more completely here. All right. So let's continue. So what we're going to do is, let's examine part E. It says x plus y is greater than or equal to 220. This means this is the line x plus y equals 220. So if I want to shade x plus y is equal to 220, I'm going to overwrite this line in red, but I must shade greater than 220. So I'm going to shade above this line. I'm going to shade above x plus y equals 220, and I'm going to highlight this line as red to demonstrate I'm also considering the points on this line, x plus y equals 220, and the points above the line. So it should look like this. Okay, so the yellow lines represent the region above x plus y equals 220, and I overwrote this line in red to show you that I'm also considering points along this line, which is the same idea for part B. I'm going to consider points directly on 4x plus 5y equals to 20, and not above but below, less than will be on this side. So it will be looking something like this, right? The red line tells me I'm considering the points on the line itself, and this orange shade tells me I'm considering points below this line. That's the region I'm considering. So, and then x is greater than y, we can interpret it as y is less than x. It's the same idea, which is the region underneath the x equals y, which will be this region. Notice I did not overwrite the line x equals y because I am not considering any point on the line as being valid to this region under consideration. So now that we have done all of that, let's examine the region that satisfies all three expressions. All right, so if you look closely, this red line here and this red line here, they will both coming to a point, they're coming to an intersection. So they should be coming to an intersection around here, approximately around here. They're going to come to an intersection, but also they'll cross at that point, but also the two lines will cross and form a very small triangle in this area here, right? And if you can see it, this area here will form a very small triangle. So I want to take that small area, expand it, and examine it more closely. So it will look something like this, where at this point, the 220 at this point here, this point is going to be the point at which the cross, which is around here, as I said before. And this whole area here is going to be this whole triangle. This point here is where lines come to the x-axis at this point and at this point. Okay, any questions here? Does that make sense? All right, awesome. Right, so this line here will be the line x plus y equals 220 crossing down this way. And this line here will be the line 4x plus 5y. Okay, this line here was going to be 4x plus 5y. And this line here is going to be x plus y is equal to 220. They will both form a very small triangle. You can't even see it. And it will look something like this. So to answer this question, what we need to do? Well, before we answer this question, definitely this is the region that satisfies all three inequalities. So that's the first thing we did right. And generally, you want to look at the points in the triangle, this point, this point, this point, and see how best they fit with answering the question itself. So the question says, determine the maximum number of hamburgers. So the maximum number of hamburgers, and pizzas. So the teacher, in all probability, will have bought both hamburgers and pizzas, all right? In all likelihood. And whereas the 225 is more than the 220, right? And the addition of this is 220 is more than this as well. And it's more than this. For both this point and this point, we have no pizzas, just purely hamburgers. Whereas for this point, we have pizzas and hamburgers. So in all likelihood, in a real life situation, this here is going to be the correct answer, and not this, and not these two. And to further, let's further examine this. We can pull up that, so it's going to be the maximum is going to be 220, and to further bolster this argument, we can see we can look at the alternative solution, right? Because they said using your graph or otherwise. Otherwise could involve equation B, which is the greatest constraint, and we can use the equality of A and B to find the maximum via two simultaneous equations. So we're going to use these two as the simultaneous equations, and if you get this solution, you're going to get x is equal to 200 and y is equal to 20. So completely in all, it's going to be 220 in all, but the maximum number will be 200 and 200 hamburgers and 20 pizzas. And again, in the real life situation, most likely she would have bought hamburgers and pizzas, okay? And not simply all hamburgers, as indicated here. So hence, we can finally conclude that the maximum number of hamburgers and pizzas teacher Mabel can buy will be 200 hamburgers and 20 pizzas. All right. Any questions there, you can put it down in the comments below. I'll appreciate all your comments and questions. All right, and with that, we've come to the end of your 100% free paper-free solutions. Feel free to contact us. We are CML Online, your CSEC mathematics expert.